Welcome to our deep dive into sound computing and AI. We're taking on 14 research papers, all from January 23rd, 2025 on the ARC-5.
All focusing on using AI for sound and music processing.
Quite the collection. We're going to extract the most fascinating insights for you.
Sounds good.
3 big themes really jump out: hybrid and multimodal approaches,
The rise of self-supervised learning.
and more efficient AI models that can handle real-world challenges.
Definitely seeing those trends.
Some intriguing examples, too. AI composing soundtracks for tabletop role-playing games.
Systems that understand emotion in speech.
Even algorithms that can enhance HRTF data for personalized 3D audio.
A lot to unpack.
Let's dive right in. The first paper is Hybrid Losses for Hierarchical Embedding Learning.
This one explores a clever solution to a common problem: recognizing sounds from categories the AI hasn't been specifically trained on.
Like, if an AI can recognize a violin and a cello, could it identify viola, even if it's never encountered one before?
Exactly. Traditional models struggle with that. This paper uses a tree hierarchy of sound labels.
A family tree for sounds.
Yeah, think of it that way. The AI learns not just individual sounds, but relationships between them.
So it learns the family of sounds, so it can make educated guesses about new ones.
Right. They combine a categorical cross-entropy loss with a hierarchical triplet loss during training. Improves the model's ability to generalize.
Fascinating. Now, this reminds me of the next paper, S-Key, Self-Supervised Learning of Major and Minor Keys from Audio. This is about AI teaching itself from unlabeled data, right?
Exactly. S-Key distinguishes between major and minor keys in music simply by listening to songs. No human labeling needed.
That's impressive.
Think about how humans learn music. We pick up the emotional difference between major and minor keys through exposure. This research is emulating that.
So S-Key uses contrastive learning, comparing musical excerpts in the same and different keys to learn distinguishing features.
Right. And it's achieving state-of-the-art performance.
Wow. This approach could be applied to other aspects of music analysis, too.
Absolutely. Imagine AI transcribing melodies or generating musical ideas without labeled data. The possibilities are huge.
Definitely. Okay, let's shift gears a bit. Let's talk real-world deployment, the domain adaptation framework for speech recognition systems with only synthetic data paper.
This one tackles a big challenge: domain shift. AI trained in one environment often performs poorly in another.
Right.
They propose using large language models, or LLMs, to generate synthetic domain-specific text, then convert that text to speech data using text-to-speech.
So instead of gathering real-world data, which is expensive and time-consuming, they create a virtual soundstage for specific audio domains.
Exactly. They use these low-rank adapters, or LoRa's. They're like lightweight add-ons to the model.
So they're giving the model a toolbox to handle different audio situations.
You got it.
That's clever. Speaking of adaptation, the next paper, BLR-MOE, Boosted Language Routing Mixture of Experts for Domain-Robust Multilingual E2E ASR, addresses multilingual speech recognition.
This one's all about tackling language confusion. Models misinterpreting words from one language as another, especially in unfamiliar domains.
Yeah, that's a tough one.
BLR-MOE uses a mixture of experts approach. Different parts of the AI specialize in different languages and domains.
Like a team of specialized chefs, each mastering a specific cuisine.
I like that.
Yeah.
And there's a router that directs audio to the appropriate expert.
This could revolutionize communication in a globalized world. Now let's move on to understanding emotions in speech. EmoTech, a multimodal speech emotion recognition using multi-source low-level information with hybrid recurrent network, and EmoFormer, a text-independent speech emotion recognition using a hybrid transformer CNN model. 2 very interesting papers.
Both explore different ways to identify emotions expressed in speech, regardless of the speaker or the words themselves. EmoTech uses a hybrid network,
combining convolutional neural networks and recurrent neural networks.
You got it. CNNs are good at analyzing spatial patterns, while RNNs excel at processing sequential data like speech. They process both audio and text to classify emotions.
Interesting. And EmoFormer.
It uses a transformer-based architecture similar to ChatGPT to analyze acoustic features like pitch and tone. They also use a CNN to extract further patterns.
And how do they perform?
Both models achieve impressive results on the EARS dataset, a benchmark for speech emotion recognition.
That's great. Now moving on, the SoundSpring, loss-resilient audio transceiver with dual-functional masked language modeling paper. This one addresses audio transmission reliability, right? specifically packet loss, which causes those audio dropouts.
Exactly. You know that frustrating robot voice we hear on video calls? That's packet loss. This research tries to mitigate that.
I hate that robot voice, so how do they approach it?
They utilize masked language models, or MLMs.
Those are typically used for predicting missing words in text, right?
Right. But here, they use them for both audio compression and packet loss concealment. Think of it as a packer that efficiently packs a box while ensuring it withstands damage in transit.
So it shrinks the audio data while adding protection from packet loss.
Very clever.
Let's talk about using LLMs to refine speech-to-text output, FlanEC, exploring FlanT5 for post-ASR error correction, and performance evaluation of SLAM-ASR. The good, the bad, the ugly, and the way forward.
Even the best speech recognition systems make errors.
True.
FlanEC uses a powerful LLM, FlanT5, to analyze multiple possible transcriptions and select the most accurate. SLAM-ASR integrates an LLM directly into the recognition process, creates a bridge between speech and language understanding.
So FlanEC acts as a judge, choosing the best option, while SLAM-ASR actively participates in the recognition process. Makes sense. Now let's shift to ethical considerations of AI and sound. The paper, Why Disentanglement-Based Speaker Anonymization Systems Fail at Preserving Emotions, caught my eye.
This research highlights the challenges of speaker anonymization. It aims to protect privacy by removing identifying information from speech, but current systems often remove emotional cues, too.
They're too focused on removing identifying features and inadvertently strip away the emotional richness.
Exactly. And the researchers found that the main reason for this is that these systems lack emotion-related information in their design.
They're emotionally blind.
In a way, yes.
That raises important questions about balancing privacy and preserving emotional expression.
Definitely something to think about. Okay, let's move on to personalized audio experiences with retrieval augmented neural field for HRTF upsampling and personalization. HRTFs are crucial for realistic 3D audio, but obtaining high-quality data is difficult.
They're like sonic fingerprints for our ears, shaping how we perceive sound in 3D. This paper explores creating personalized 3D audio experiences.
They use retrieval augmented neural fields, or RANFs. They retrieve similar HRTFs from a database and use a neural network to upsample the data,
Creating a more detailed representation, like increasing the resolution of an image, but for sound.
Exactly. This could revolutionize immersive audio experiences.
For sure. Now let's discuss speech enhancement in noisy environments with Decoding, guided anisotropic lightweight diffusion for efficient speech enhancement. It uses a diffusion model, a generative AI usually used for image creation.
This model adds noise to a speech signal and trains a neural network to reverse the process. It learns how to denoise the speech.
Okay.
GALDC introduces noise with anisotropic guidance. It's tailored to the specific characteristics of the speech.
So it adds custom-designed noise to the speech signal and trains the AI to clean it up.
Yes, and it achieves impressive performance.
It's like having a super effective, energy-efficient, noise-canceling headphone.
Great analogy. Okay, finally, let's delve into AI's creative potential in sound with long-form text-to-music generation with adaptive prompts. A case of study in tabletop role-playing game soundtracks.
AI composing music. This always captures my imagination. This paper goes beyond background music, creating dynamic soundtracks that adapt to the story.
It's called BabbleBardo. It combines large language models and text-to-music generation. It analyzes speech transcriptions, identifies key events and emotions, and generates music descriptions to guide the music creation.
It's like having a personal composer adapting the music in real time to match the mood and action.
Precisely.
Amazing. Last but not least, let's discuss evaluating audio technology with semi-intrusive audio evaluation, casting non-intrusive assessment as a multimodal text prediction task.
Traditional audio quality assessment relies on subjective listening tests, which can be unreliable. This paper proposes a more objective approach, framing evaluation as a multimodal text prediction task.
So the AI analyzes the audio signal and a text description of the audio to provide a nuanced assessment, like giving the AI a vocabulary to describe the quality of the audio. This could revolutionize how we measure the performance of these AI-powered audio technologies. We've covered a lot of ground today. What are your key takeaways from these papers?
We're seeing the rise of hybrid and multimodal approaches, self-supervised learning, and a focus on efficient and robust AI.
It's clear that AI is transforming how we create, experience, and interact with sound.
It's really remarkable the progress being made, so much potential in these advancements in sound computing.
It really makes you wonder how these technologies will shape, well, our sonic landscape, I guess. But, as we dig deeper, it's important to consider the ethics involved.
Absolutely. As AI becomes more integrated into our lives, responsible and ethical development becomes even more crucial.
The paper, Why Disentanglement-Based Speaker Anonymization Systems Fail at Preserving Emotions, that really brings this challenge to light. It looks at speaker anonymization and those unintended consequences, removing emotional cues from speech.
And speaker anonymization, it's essential in a lot of situations, right? To protect privacy.
Yeah, absolutely.
Think about whistleblowers, confidential conversations, even research data sets where you need to protect identities.
Right. It's like giving someone a vocal disguise, allowing them to speak freely without fear of recognition.
Yeah, that's a good way to put it.
But, as the research points out, the current methods often struggle to preserve the emotional richness of human speech.
They're designed to remove those identifying features, and in doing so, they often strip away the emotional nuances that convey so much.
It's like focusing so much on erasing the speaker's vocal fingerprint that we accidentally wipe away their emotional expression.
Yeah, that's a good analogy. And that can have some pretty big implications. Imagine a therapist using anonymized recordings for research, right? If those emotional cues are missing, they might misinterpret the patient's true state of mind.
Or even in a legal case, where the emotional tone of a recording is crucial evidence. Anonymizing the speech without preserving those emotions could completely change how that conversation is understood.
Right, exactly. So it really highlights the importance of finding ways to anonymize speech, but while still retaining its emotional depth.
Finding that balance. The researchers suggest that the systems are failing because they don't have emotion-related information in their design, like they're emotionally blind.
Yeah, that's a good way to think about it. The solution might be to develop new approaches that specifically incorporate that emotional information into the anonymization process. It's not just about removing those identifying features, but also understanding and preserving, like you said, the speaker's emotional fingerprint.
Yeah, it's a delicate balance, for sure. Okay, let's shift gears a bit and look at a paper that explores how AI can enhance our individual experiences with sound. Retrieval Augmented Neural Field for HRTF Upsampling and Personalization.
This research tackles the challenge of creating personalized 3D audio experiences, and it uses HRTFs, or head-related transfer functions. You mentioned earlier that they're like sonic fingerprints, shaping how we perceive sound in 3 dimensions.
They're unique to each person, influencing how we locate sound sources and experience spatial audio.
Exactly. And this paper explores a technique called Retrieval Augmented Neural Fields, or AAFs, to create personalized HRTFs efficiently.
Now, the traditional method for obtaining HRTFs, it's complex, right?
Yeah.
You need specialized equipment, a controlled environment. RANFs offer a more accessible approach.
Right. They work by first searching a database for HRTFs that are similar to the target person's HRTF, essentially finding their sonic doppelganger, so to speak.
Interesting.
Then a neural network is used to upsample the data, increasing the spatial resolution, creating a more detailed representation.
It's like taking a low-resolution sonic snapshot of someone's ears and using AI to enhance it, creating a high-fidelity 3D audio experience tailored to their unique hearing.
Oh, that's a great description. Very vivid and accurate. This approach has the potential to revolutionize how we experience 3D audio, Everything from gaming and movies to music, even virtual communication.
It's a tantalizing glimpse into the future of personalized sound. A world where everyone can enjoy immersive 3D audio that's perfectly tuned to their individual hearing.
Absolutely. Now, speaking of personalized sound, let's move on to another paper that addresses a common frustration. Noisy environments. GAL-DA, Guided Anisotropic Light Rate Diffusion for Efficient Speech Enhancement. This one looks at how AI can improve speech clarity in challenging acoustic situations.
Yeah, we've all experienced that struggle. Trying to have a conversation in a crowded restaurant, a busy street, even a room with lots of background noise. It's a problem that's plagued audio engineers for decades.
And traditional noise reduction techniques often fall short. Either they don't effectively remove the noise, or they introduce unwanted artifacts that distort the speech.
Right, you get that weird, unnatural sound.
Exactly. This paper proposes a new approach using a type of generative AI model called a diffusion model.
Now, these models, they've been making waves in the world of image generation, right?
They have, yeah. But it turns out they're also quite adept at tackling audio challenges.
Interesting.
The basic idea behind them is to intentionally add noise to a signal. Then they train a neural network to reverse that process, essentially teaching it how to denoise the signal.
Okay, so you're taking a clear recording, adding a layer of static, and then training the AI to remove that static and restore the original recording.
Exactly. And what's innovative about GALDC is that it introduces noise with anisotropic guidance. That means the noise isn't added randomly, but in a way that's tailored to the specific characteristics of the speech signal.
So you're adding a custom-designed layer of noise that's specifically tuned to the nuances of the speech.
Precisely. And this approach leads to some impressive results. GALDC achieves state-of-the-art performance in speech enhancement tasks, effectively removing noise while preserving the clarity and naturalness of the speech.
It's like having a super-powered noise-canceling headphone that can filter out unwanted sounds while leaving the desired speech intact.
A fitting description. And this technology has the potential to significantly improve communication in so many applications. Hearing aids, voice assistants, video conferencing, even live music performances.
It's a step towards creating a world where we can hear each other clearly, no matter how noisy the environment.
Now let's shift gears again and explore a paper that highlights AI's creative potential in sound. Long-form text-to-music generation with adaptive prompts. A case of study in tabletop role-playing games soundtracks.
AI composing music always gets my imagination going. This paper goes beyond just generating background music, though, right? It looks at how AI can create dynamic soundtracks that adapt to the story as it unfolds.
Exactly. The system is called Babel-Bardo. It combines large language models and text music generation to create these immersive, responsive soundtracks.
Imagine a group of friends gathered around a table, embarking on an epic adventure. As they describe their actions, the music seamlessly adapts, mirroring the emotions, the tension of the game.
That's the idea. Babel-Bardo analyzes those speech transcriptions from the game, uses a large language model to identify those key events, emotional cues. Then it uses this information to generate detailed music descriptions that guide the text-to-music model.
So it's like having a personal composer right there in the game with you, adjusting the music in real time to match the mood, the action.
Yeah, a fantastic analogy, and the results are pretty remarkable. It creates soundtracks that are not only high quality, but they're also deeply intertwined with the narrative and emotional arc of the game.
It's a testament to AI's ability not just to imitate human creativity, but to augment it, enhance it. It opens up all these new possibilities for interactive storytelling, entertainment.
Now, after exploring all these fascinating applications, it's important to address, the fundamental challenge of evaluating the quality of these technologies. And the paper Semi-Intrusive Audio Evaluation, Casting Non-Intrusive Assessment as a Multimodal Text Prediction Task, tackles this very question.
Right, because traditionally, audio quality evaluation has relied on subjective listening tests, which can be time-consuming, expensive, prone to bias.
Imagine trying to judge a singing competition based only on the opinions of a few judges, right? It's subjective.
Exactly. And this paper proposes a more objective and efficient approach called semi-intrusive assessment, leveraging the power of AI.
This method frames audio evaluation as a multimodal text prediction task. The AI model analyzes both the audio signal and a text description of the audio, such as a subjective rating or a detailed description of the perceived quality.
So you're giving the AI a vocabulary to describe the nuances of sound, allowing it to provide more insightful and objective assessments.
Yes, a good way to put it. The AI, in a sense, becomes an audio critic, able to articulate why something sounds good or bad.
This approach has the potential to revolutionize how we measure the performance of these AI-powered audio technologies, right? Providing more reliable and consistent evaluations.
Absolutely. And this leads us to our final paper in this deep dive, a paper that circles back to the creative potential of AI in sound.
I'm all ears.
This paper, titled Harnessing the Power of Generative Adversarial Networks for Realistic Footstep Sound Synthesis, explores the world of sound design.
Footstep sounds. That sounds incredibly specific. Why focus on something, well, seemingly so mundane?
Well, footsteps are actually a crucial element in many forms of media, from films and video games to virtual reality experiences, even music production.
I suppose you're right. A well-placed footstep can really add to a scene. The realism, the tension, even humor.
Exactly. And creating realistic footstep sounds, it's more challenging than it might seem. It involves considering the surface material, the speed and weight of the person walking, the acoustics of the environment.
So it's not just about finding a generic footstep sound effect. It's about creating sounds that are tailored to the specific context.
Precisely. And this is where generative adversarial networks, or GANs, come in. GANs are a type of AI model that excel at generating realistic data, images, videos, text, and in this case, audio.
So they're using AI to create, like, custom-made footstep sounds.
Exactly. The researchers trained Jan on a data set of real footstep recordings, a wide range of surfaces, walking styles, and environmental conditions.
So the AI learned the intricate nuances of how different footsteps sound.
Precisely. And the results are quite impressive. The Jan is able to generate highly realistic footstep sounds that are nearly indistinguishable from real recordings.
Wow. It's like having an AI Foley artist at your disposal, ready to create the perfect footstep for any situation.
A fitting description. And this technology has the potential to streamline the sound design process, making it much easier and faster to create those immersive and believable audio experiences.
This deep dive into the world of sound computing and AI has been incredibly illuminating. We've seen how AI is pushing the boundaries of what's possible, from enhancing speech clarity and personalizing audio experiences to generating realistic sounds and even composing dynamic soundtracks.
It's an exciting time to be working in this field. The possibilities are truly vast.
Indeed. And as we wrap up this episode, I'm filled with a sense of wonder and anticipation. Can't wait to see how these technologies continue to evolve and shape our sonic landscape in the years to come.
I share your enthusiasm. The future of sound is bright, and AI is leading the way.
As we conclude this deep dive, we invite you, our listener, to think about this. How do you envision AI shaping the soundscape of your life? What sonic dreams do you hope to see realized?
Let your imagination run wild. The future of sound is waiting to be heard.
Thank you for joining us on this exhilarating exploration of sound computing and AI. Until next time, keep your ears open and your sonic curiosity alive.
Happy listening.
Wow, what a journey this has been. This deep dive into sound computing and AI has been truly eye-opening. I'm amazed by the ingenuity and creativity we've encountered.
It has been exhilarating, exploring how AI is transforming so many different aspects of sound.
Before we wrap up, let's take a moment to reflect on some of the key takeaways that have emerged from these 14 papers.
One of the most prominent themes is the rise of those hybrid and multimodal approaches. AI systems are moving beyond just analyzing a single type of data. They're integrating audio with text, visual information, even other sensory inputs.
Like AI is developing a much richer understanding of the world, a more holistic view, kind of like how we humans experience it.
Exactly. And this multimodal approach allows AI to perform more complex tasks, creating systems that are much more robust and versatile.
Another big trend we saw is the growing use of self-supervised learning. AI learning from huge amounts of unlabeled data.
This is really a game changer. It frees us from the limitations of those labeled data sets, allowing AI to tap into the wealth of raw data that's out there.
It's amazing to see AI's ability to learn and adapt, uncovering hidden patterns and connections that we might not even be aware of.
And we can't forget the increasing focus on the ethical side of AI development. As these technologies become more powerful and widespread, we need to ensure they're implemented responsibly and ethically.
It's a critical consideration. We need to think about the potential consequences and make sure we design systems that align with our values and prioritize the well-being of society.
It's our responsibility to make sure technological progress goes hand in hand with ethical progress.
Looking ahead, what are your thoughts on the future of sound computing and AI?
Well, I think we're on the verge of a sonic revolution. AI will reshape how we create, experience, and interact with sound in profound ways.
Wow, a sonic revolution. What kind of exciting possibilities do you see emerging on the horizon?
I can imagine AI becoming an indispensable creative partner for musicians and composers, helping them push artistic boundaries and explore uncharted sonic territories.
Like an AI muse, constantly inspiring new ideas and possibilities.
Exactly. I also see AI playing a crucial role in making audio more accessible and inclusive. Personalized audio experiences that cater to individual hearing needs, preferences, even emotional states.
A world where everyone can fully enjoy the beauty and richness of sound, regardless of any limitations.
Exactly. And I think our sonic environments will become more intelligent and responsive. Imagine smart homes that adjust soundscapes to match our moods and activities, creating personalized sonic experiences.
Like having an AI DJ for life, curating the perfect sonic backdrop for every moment.
And let's not forget AI's potential to deepen our understanding of the world through sound. AI could analyze complex soundscapes, revealing hidden patterns and insights, from the hustle and bustle of city streets to the delicate sounds of a forest.
Like AI is giving us superhuman hearing, allowing us to decipher the intricate symphony of sounds that surround us.
The possibilities are truly limitless. The research we've discussed is just a glimpse of the amazing sonic innovations to come.
This entire deep dive has filled me with a sense of excitement and wonder. I can't wait to see how these technologies unfold and shape our world of sound in the years ahead.
I'm right there with you. The future of sound is bright, and AI is composing a symphony of innovation that will be unlike anything we've ever heard before.
As we wrap up this deep dive, we invite you, our listener, to join us in this journey of sonic exploration. How do you envision AI shaping the soundscape of your life? What sonic dreams do you hope to see realized?
Let your imagination run wild. The future of sound is out there, waiting to be discovered.
Thank you for joining us on this exhilarating exploration of sound computing and AI. Until next time, keep your ears open and your sonic curiosity alive.
Happy listening.